Hello and welcome to the next lecture about counting sort. Today we will go through the implementation of counting sort using the Python programming language. Before moving on with this lecture, I highly recommend watching the introductory lecture, which is provided in the above link to grasp the intuition behind counting sort. Now let's dive into the code by calling the counting sort function. Suppose we are given this array. The two first lines indicate an auxiliary array in which the length is equal to max plus 1. Firstly, we must find the maximum element and the length of this auxiliary array will be equal to max plus 1. In a nutshell, this is because we want to ensure that there is enough space to accommodate all possible values within a range between 0 and a maximum number. In a simpler term, for example, if you have a list of values ranging from 0 to 10, you would need an auxiliary array of size 10 plus 1 to accommodate all possible values since indexing starts from 0. Therefore, initialize a list with a size of 9. Counts each unique element and update the counts array accordingly. Please note that the terms auxiliary array and counts array are used interchangeably to refer to the same array. We go through input array and we will update the occurrences of each unique element in the counts array. Additionally, in the next section, we must sum up elements with their predecessor, or in other words, we must calculate the cumulative sum of counts. And finally, sort the array and put elements in the output array. Let's take a look at what's happening. To do this, we'll use a for loop that begins with the last item of the input array. Move to the next line and we have a variable named value that ARR of j has been assigned to this variable. I have discussed how to place an element from input array into the output array in its correct position. You can refer to the link provided in the description, but once again, I will provide a quick recap. In the counts array, the element with a value of 3 appears 6 times. In simpler terms, there are 6 elements less than or equal to 3. For instance, here we only have one element greater than 3, so we need a space for that item. Otherwise, if we put element having a value of 3 at index 6 of output array violates the stability of counting sort, because in that case there is no remaining space for the element with a value of 8 given the ascending order of the output array. Now we must decrement the occurrences by 1 in accordance with the fact that indexing starts from 0, and to ensure we have enough space to accommodate the same value if it is encountered again. As it is observed, when we decrement 6, it becomes 5, and this 5 is the correct index of the element having a value of 3. So we put 3 in the correct index of the output array. And this line of code, which is counts of value, will hold the last state of the counts array. In a simpler term, by decrementing the count of that value, the algorithm is updating the state of the counts array to reflect that one occurrence of that value has been processed and placed in the output array. This is crucial for maintaining the correct count of occurrences of each value in the counts array as the algorithm progresses. Move to the next line to observe what happens there. We come across another element with the same value of 3. Now check the counts array to examine how many times the element with a value of 3 appears. After decrementing by 1, we position the second element at index 4 of the output array. This time j is equal to 4, and in the next line ARR of j is equal to 8. Go to the counts array to investigate the correct index of the element having a value of 8 to find its correct position in the output array. Index 6 is the correct index for the item with a value of 8. Let's speed up the process and place 3, 0, 1, and 2 in the correct indices of the output array. Do the same for the remaining elements. The process is simple and straightforward. Please keep in mind that for sorting the array using counting sort, it is essential to carefully update counts, ensuring the stability of the algorithm and precisely placing elements in their sorted positions. Now the array is sorted and I hope you enjoyed learning. Thanks for watching this video.